คือมันมีสายเสียงใช่ไหมนี่ได้แล้วจะได้ไหมใช่ไหมนะเดี๋ยวลองเสียงเลยพอดีมีโชว์วิดีโอแล้วมันโอเคขอบคุณครับได้ขอบคุณครับโอเคสถานพูดก่อนโอเค
Okay, so today it's an honor for us to have professor from Mayor University, Professor An Chayo. Actually, he is a lecturer at Mayor University ICT, but and his expertise in the field of software engineering. Okay, he was graduated from Kazakhstan University. I've known him for a long time. But actually, I'm his student when I was trying to understand about the Android programming. So up to now, he was graduated from UK, United Kingdom. And today is an honor for us to have him to give a lecture and talk today. So if you have any questions, please feel free to ask him. Okay, please give him the hands for this lecture today.
Thank you, Anantam, for the introduction. So it's an honor to be here. I'm happy to be here. Is it my first time at KMUTT? Like ever? So this is a bit new to me. So let me introduce myself a bit. I'm Chayong Rakit Wesekun. You can call me Ajahn An. Okay. And I'm an assistant professor at the Faculty of ICT, Mahidol University at Salaya. You have any friends there in Salaya? Yeah. So the Faculty of ICT is computer science. Actually, it's a computer science program. So I teach software engineering courses like Introduction to Software Engineering, software design and development, software quality assurance and testing. So mostly I teach everything software engineering, okay? And I do research about software engineering as well. Analyze software, trying to improve the quality of the software, so on and so on, okay? And I am a consultant for software companies in Thailand. So there is a standard called ISO 29110 that is the software engineering standard for small software teams. So I have been working with Thai software companies for many years now, trying to adopt these standards, okay, in their software development process. So if you have any questions, feel free to send me an email here, or you can see more about myself at the website here. Okay, we are from this software engineering research unit, CERU, at the Faculty of ICT. Okay. Okay. I wish I use another set of slides. I have a podcast too. If you want to listen to a podcast, I have a podcast called SE Corner. You can find it on mostly any podcast provider. Okay, but I talk in Thai though. But if you are Thai, you can still listen anyway. So I mostly cover topics related to software engineering, how to develop software, productivity, software design, and like AI for software development and so on. So feel free to check it out if you feel interested. So I will not only teach today, but I will be teaching this week and the 3 weeks after this. Okay, so you will see me for quite a number of time. I will cover the topic of architecture, which is today. And then next week, I will tell you about low-code programming, which is a new paradigm of software development. Oops, sorry. And then the week after, we will talk about version control, and some tips for implementation. Okay. And lastly, in week number 4, we will talk about testing. Okay. How to design test cases and how to perform systematic tests of your software. So let's focus on today. So today will be mainly about software architecture and design. Sorry, I forgot the design part, which is one of the most important aspects in software development. Before start developing the software, you need to understand what are the architectures that we're going to use and how do we create like a blueprint of your software so that everything will be implemented correctly and it's easy to maintain. Okay. So the design architecture starts from requirements. Everything in software starts from requirements. You know requirements, right? What the customer wants, right? So the requirement tell us what the customer wants. And requirements can be categorized into two types. Have you, I'm not sure whether you have learned this one. So there are first, functional requirements. 2, non-functional requirements. ได้เรียนไหม Functional and non-functional requirements. Functional requirements usually tell us what are the functions in the software or what the software can do. Okay, you list the features that the software can do. Login, register, payment, make a payment, search, browse the product, so on and so on. So these are called functional requirements. It tells what the software can do. But non-functional requirements usually answer the other question, which is how the software does it. Non-functional requirement consists of other aspects of the software, such as speed. 2 software programs can have the same exact functionalities, but they can be different in speed. The first one can log in within 1 second, but the second one can log in 2 minutes. So these are non-functional requirements that are different. Okay. Not only speed, there are also other types of non-functional requirements, such as security. Okay. One banking application is not secure. Like it doesn't encrypt your password whatsoever. And the other banking application is highly secure. So we are more happy to use the one that is secure, right? So even though they have the same function, but the non-functional requirements are different, and that affects the satisfaction of the user as well. The third one is reliability. What is reliability? How long the software can operate, right? If the software has high reliability, it can operate like 24/7. But if it has low reliability, it might be down for every day or so. And the one that has higher reliability is the one that is better, right? So what else? Can anybody think of other types of non-functional requirements? Can you go? What are the other aspects of software that differentiate how good it is, such as speed, security, reliability? What else? Compatibility, good one. How compatible is the software? Like, can you use it on multiple types of hardware or not? Or does it use across multiple platforms, iOS, Mac OS, Android application? There can be a few more. Okay. Can you help me? What is the other one? Security. Something about beautifulness. Yeah. Availability. So availability can be computed like 99.999% of the time. And UI and UX is also part of the non-functional requirements, right? How beautiful. You can do the same functionality, but one app is so ugly and the other app is so beautiful. So that also affects the user satisfaction. So that's the requirements, right? You have functional and non-functional requirements. Then we need to think about how would we build the software so that we can satisfy such a set of requirements. Okay. We have the requirements. The requirements usually got translated into two things. So first, when you read the set of requirements, R1, R2, R3, you would need to think about, what kind of architecture that I should use for this software so that it answers these requirements. The architecture mostly will need to consider the non-functional requirements. And mostly it relates to scalability. We haven't talked about scalability. Scalability is how scalable it is, how much user that it can accommodate, or how many transactions that it can accommodate over time, right? So also something about security might also relate to the architecture as well. Okay, so when we read the requirements, we think about the architecture, and at the same time, we find a way to convert those requirements into the actual implementation. Now, so this is the actual code that you have in your software. So today we're gonna talk about two parts. I'm gonna talk about the overview high-level architecture first, and then we go into more detail about the detail design or the code level. Okay. So we have many modeling techniques that help us understanding the requirements and trying to turn those requirements into the actual software. Okay. Some of them you might already study, like class diagram. No, class diagram. You have studied class diagram, right? So class diagram is called class-based model, or it is a structural modeling. You try to understand what are the structure of the code in your software. And there are also other types of modeling like use case models. Do you know use case model? Yeah. So use case model is called scenario-based modeling. We don't care about the structure, but we try to understand what are the scenario that the user can do. Can do with the software. Okay, and there are other types of modeling like data flow. You study data flow diagram, DFD. Yeah, so that is flow-oriented modeling. And other types of modeling like behavioral modeling, like state diagram, sequence diagram. Okay, these modeling tools help us to trying to convert the requirements into the actual software programs. Okay. So let's get started with the top level one, architectural design. Okay, we want to consider the following factors. When you study the requirements and you want to design the software, you might need to think about what should be the hardware that I will install this software and make it run for the users. What should be the architecture of the software itself? Okay, and is there any other infrastructure that are needed, like networking or some other type of special hardwares? Okay, and for this physical architecture layer, we mostly focus on the non-functional requirements that we have discussed before. It affects the performance, security, culture, even operation of the software that you have. Okay, so we're gonna talk about a few things. Okay, we're gonna talk about both hardware and software aspect of the physical architecture. Okay, I'm gonna start with the hardware component first, and then we're gonna talk about the software ones. So for the hardware components, you would have three main categories of designing the architecture. The first one is called server-based. Okay, I'm gonna talk about the detail of each one. The second one is called client-based, and the third one is called client-server architecture. The first one is server-based architecture. So the server-based architecture, everything mostly depends on the server. The server contains the data, the server contains the data access, the server provides the application logic, and the server also provides the presentation logic. The user use the software using the client just for getting into the server, and this is mostly done by using the terminal, something like SQL shell. Have you tried using SQL shell, like remotely log in, right? So that is server-based architecture. This one, everything 100% is on the server. The second type of architecture is the totally opposite. It is called a client-based architecture. So for client-based architecture, the server only has the data, and the rest of the logic, data access, application, presentation are on the client side. Okay, this is not very popular nowadays, but there was time in the past that you would have a database that is stored on the server, and then you would have a local client programs that connects directly to the database and pull and push the data and then make some calculations. Okay. The one that we are more familiar with nowadays is called client-server architecture. So client-server architecture has both parts, and each part responsible for some logic in the software. So you can have the first type that is called thin client and fat server, which means you have more logic on the server part and less logic on the client part. One example of the thin client and fat server is, for example, you have an application that mostly just being a facade or just retrieve and show information like Instagram, Facebook. But most of the computation or most of the data and the logic stored on the server. When you upload an image or a photo to Instagram, everything was sent to the server, right? And all the feed information, all the photos that you see come from the server. Client acts just as the UI for you so that you can see and retrieve information. The second type of client-server architecture is fat client and thin server. So for fat client and thin server, you would have more logic on the client side. I think one clear example of this is games, right? For example, if you have computer games, I just play Diablo 4, very old. No? It's like the game of when I was young. So Diablo 4, you have to install a game on your computer, and it takes like 10 gigabytes or even more than that. So lots of logic stored on the client. Also, if you play mobile game, like I don't even know what games. Game I have. What are the games on the mobile now? What game that you play? Oh, that's right. Oh, so old. That was like when I was high school. So last section they told me like Valorant, ROV, that kind of thing. You install the software on the client. The software is big, usually it's huge, right? It contains the model, it contains a lot of things in the game. And the server has only the parts that coordinating between the clients. What you send to the server is the information. Like if you play first player shooting game, Counter Strike ใหม่กว่านั้นมีไหมอะไรนะของบริษัทValorant นี่ก็เป็น first person shooting ใช่ไหม Overwatch the data that is sent to the server is the coordinates that you are located, right? It's a tiny amount of information, but the most of the things, the rendering of the characters and all the interactions, it happen on the clients. So this is considered a fat client and thin server architecture. So when you design a software, you might need to think about what should be my architecture. Is the logic supposed to be more on the server or the logic supposed to be more on the client? And then you have to choose accordingly, okay? And then people start adding more and more layers or adding more and more tiers into the architecture. So you can have 3-tier architecture that you have the database server, you have the application server, and you have the client server. The database server responsible for all the data related tasks. The application server responsible for the application logic. And then the client only be the presentation of the software. Okay, so 3-tier architecture is the one that I think used the most nowadays. You have server that are database server, and then you have another server that is an application server, and then you have your client that acts as a presentation layer. Okay. In terms of the software or the framework that you install on each of the tiers, on the database layer or the data access layer, you would install these DBMS, right? Database Management System. And these would be all the programming frameworks. And on the presentation layer, usually they are the UI frameworks, like HTML, JavaScript, React, Vue. What else? There are a lot nowadays. So let's say 3 tiers are separating the logic out across multiple layers. Okay. And we can keep going on. You can have 4 tiers that have the data access logic, and have the non-web logic, and then you have the web logic, and then you have the presentation logic. So people keep inventing many more kind of architecture. There are also some kind of pre-packaged architecture solution that you can buy. So if you are developing some kind of application that fit within some specific problem domain, you can reuse these architecture that they have invented. Like this one is called Oracle Fusion Middleware Architecture that consists of data tier, middle tier, web tier, and in each one of them there would be many components inside. This is Oracle, so they use Oracle technology. Oracle is a very big database provider, right? Oracle database. So these are another proprietary architecture. Now, proprietary means specific to one company. Like if you buy Oracle architecture, you might need to use their software and all the framework that they provide to you. And yeah, you can have these 4 tiers in a different way: service tier, aggregate tier, delivery tier, client tier. I won't go into detail. But the benefit of client server is a lot, so that's why it is being used and it's very popular nowadays. It has scalability. You can increase the amount of server or the spec of the server as much as you want, right? Especially nowadays when we have these cloud providers and you have the machine that acts as a server on the cloud. You can adjust the machine spec very easily, increase the RAM, increase the hard drive, increase the CPU, so on and so on. And by having client server architecture, you can support multiple clients at the same time. Okay. And they are talking to each other using basic internet standards such as HTTP or REST protocol. So you can pull out the presentation logic and you communicate using like JSON data, right? So this is what we are doing nowadays. So that is physical one, like the servers. How would you divide the servers? Now let's talk about the software. Okay, so software itself also has an architecture. When you create a software, inside the software, we need to think about what are the modules and how they are connected, how they are talking to each other. So we call this one of them as software elements. Okay, and how would we create them so that we can have them to have good relationships, which means how would they be organized so that we can be easily maintain them, no? Easily maintain. And there are some of the software architecture that I'm going to talk about today. So when we are creating a software, we start from the customer requirements. The customer tells us that he or she wants 4 bedrooms, 3 baths, lots of grasses. Let's say that this customer is building a house, right? And the architect, Satapani, would be the one that draws the blueprint according to the requirements. So software is the same. If you think about building software as building a house, you would convert the requirements into software design, software architectural design, so that the software team, you know what to build and they are on the same page. So these architectural styles work as a documentation for our team so that everybody knows this is the thing that we are going to build. And it's also an easy way to communicate among the stakeholders. You can show the architecture to the system, software system team, the one that prepared the server for you. You can show the architecture to the customer so that they know this is the software that you are developing, so on and so on. Okay. There are multiple software architectural styles that we are using in the past and also nowadays. Okay. I'm going to start with the first one. The first one is called pipe and filters. So pipe and filters are the architecture that is very simple and it is based on sequential computation. Which means you have the first one sending an input to one module. That input comes out as an output and now becomes the input for the next one. And then the next one create the output and that output becomes an input for the next one. So if your software has this type of uh, พอดีมันจอยใหม่ขออภัยso this staff class can do so many various things. It can even print a letter, which might not be related to a staff, right? Compared to the right one, when you have a staff class that has salary and email, and you have this set salary, get salary, and then you have set email and get email. Okay. So the right one is the one that has better cohesion. So this one has high cohesion, while the left one has low cohesion. You have random things that are not supposed to be together in the same class. The cohesion level can be different. There are many levels of cohesions, but I don't go into detail. Okay, but the lowest level of cohesion is called coincidental cohesion, which means everything just being put together. Coincident ก็คือit happens by random coincidence. You don't aim, you don't plan for anything. So coincidental cohesion is you have one unit that has many unrelated contains unrelated pieces of code. On the other hand, if you have the highest level of cohesion, we would have one single unit that only perform one single function or one single responsibility, like staff class, do everything related to the staff, student class, doing everything that relates to the student. Okay. So for cohesion, the higher, the better. We want high cohesion. Okay. So far, so good. No. Next one is called coupling. Coupling is the degree of interdependence. What does it mean? Okay, when we talk about cohesion, we care only this single module. So this is module A, this is module B, this is module C, and this is module D. When we do cohesion, we only care about the inside of the module. Okay, we want to put things that are related into the same module. But for coupling, we care about how are they connecting to each other. In this case of a software, it means you make method calls or function calls. Let's say module A rely on some function in module C, so you have this arrow coming from A to C. Module C depends on some function in module A, so you have this arrow going to A, and so on and so on. Okay. So coupling cares about how much the module are depending on each other. Okay. How much the modules depend on each other. And for coupling, it is opposite to cohesion. You want lower coupling because when we have highly coupled software, you would have a lot of interconnections, right? And when you have many interconnections, possible that we might have something like this. You have class A. Let's say you have a class A and you have another class B. Class A has function X, function Y, and function Z. Class B has function 1, function 2, and function 3. Function X call something in class B, function 1. Function 2 depends on some code in function Z in class A. When you start writing it, there are not much of the problem, but the problem comes when you have some changes. So when you have some changes in this function, it is very possible that you might also need to modify this F2 function, because if you change something there, this one depends on it, then you might need to change F2 as well. Things get worse if F3 also rely on F2, rely on F set, because when you modify F set, you need to modify two things here, right? So that's why you don't want to have so many connections between the module, because when there is a change, that change might be propagated into multiple other related modules, and then you have to make follow-up changes as well. So for coupling, the lower, the better. We want the module to be mostly independent, and there are only small number of interconnections between the module. No dependency is ideal case and never exists. You cannot have software that doesn't have any connections. That would be totally weird, right? You might have 4 different programs, but if it's the same program, it is impossible that the 4 modules in the software are not connected to each other. So there will be some level of dependency, but you don't need to make it too much, too highly coupled. So for coupling, the lower, the better. The lowest level of coupling is called data coupling. I think this one needs to be here. Sorry about that. No, that one is no coupling. This is ideal but not practical. But data coupling, you only pass the necessary information. Okay, you pass only necessary information when you make method calls. When making method calls. And the worst level of coupling is called content coupling, when you access internal data of another data structure. So for example, if you have a student class, the student class has name, and you have another class called registration. The registration class has a method register, and the method register access this name variable directly from another class object. That would be the worst type of coupling. Have you ever wrote a class with everything public? If you're not, then it's good. But if you make everything public, then everybody can modify your data directly without that class knowing. So that is the worst type of coupling, and it's called content coupling. So for coupling, the lower, the better. I would like to show you one example of the data coupling. Data coupling, one example is that we have 2 modules. The first one is module that retrieves the customer information. The customer information can be name, age, address. Okay. This module cannot have the address by itself. It has to get from another module called retrieve customer address module. So we need to make some call from the top one to the bottom one. If you want to make it the low coupling, the lowest coupling as much as possible, you would send only the needed information. So by getting the customer address, we don't need to send the name. We don't need to send the age. We need to send only the customer ID. Okay. And by sending only the customer ID, you get only the address back. And that would be enough. So if we have data coupling, you usually just send only primitive data type. Like you send a string, you get an integer back. You send an integer, you get a string back, so on and so on. When you start sending an object, or when you start sending some lists or maps, those complex data structure, they are usually not data coupling anymore. You start to have to depend on some assumption from the other class that you rely on. Okay. So to sum up, data coupling works by sending only necessary information. Okay. So combine them together, we want high coupling, high cohesion, sorry. So cohesion is good when it's high, and coupling is good when it's low. Okay. And let's try some simple exercises. So we have two different type of implementation. So you have option A and option B. In this question, option A says the print routine. Routine is pretty over. We might say method. The print method of the customer billing takes the customer name. It takes the customer name. It takes an address. It takes billing information as an argument, and then it prints out those information. The second variation, option B, the print method accepts a customer data structure, and then it extracts the name, the address, and the billing information, and then it prints out the information. Which one has higher cohesion? I walk down, so you know I'm gonna ask someone. Which one? Which one has higher cohesion? A or B? Okay, can you break it down? A or B? Yeah. B. The answer is A. So if we look at the information that we have here, option A receives one specific data, like it receives customer name, receive an address, it receives a billing information, compared to option B that you pass the whole customer data object to it. Okay, the first one is data coupling. You pass only the data, but the second one is not. So the second one has some risk that the data structure of the customer might change, and then the print method might not work, right? So let's say if somebody modify the customer data structure by removing some of the attributes, then the print routine would not work anymore. Next one. This one I showed you before. So this is data coupling. Okay. You have pass only the data that is needed. This one is the worst one. This one is content coupling, where you get the data from the same place. For example, if you create a program with some global variables, have you ever written a program with global variable? I think so, right? It is not a good practice actually, but in some cases it needs to be done. I understand, but we need to reduce the amount of these global variables, because if there are multiple modules that are using the same data, and if one module is modifying that data, it might affect the whole other modules, right? So that's why we have the concept of encapsulation in object-oriented programming. You need to do private, public, because you want to control the access of information. Okay. Another question. Option A file reader module is designed to handle file input operations. It has the methods for opening, reading, and closing files. This one is about cohesion, by the way. The second option, option B, data processor module combine various functionalities. It includes methods for reading data from files, performing mathematical calculations, and also sending emails. Which one has higher cohesion? Which one has higher cohesion? A or B? Higher the better, right? Dah. B. Oh, I thought A. If you look at here, it says a file reader module is designed to handle file input operations, right? So the file reader module is supposed to do everything related to files. And it has opening, reading, and closing files. So everything is related to a file. That is good in terms of cohesion. Compared to module B, it does reading a file, do mathematical calculations, which might not be totally related to the file, and also can send an email. So this is one example of code with low cohesion. You just mix random things together into one single module. Make sense? Okay. Another one, longer. The left is you have an employee database module. Okay. That is a core component in HR system. It has the functionality related to employee data by adding new employees, updating existing records, generating reports, calculating payroll. This is A. B is a utility module that perform various functionalities like file operations, mathematical operations, and also do some UI interactions. Which one has higher cohesion? Which one has higher cohesion? A, yeah, that's correct. So A is a module that do everything related to employee, right? So all the functions related to employee. But this one are mix of random things, right? Mix of many things. So this one has high cohesion. This one has low cohesion. Okay? Make sense? No? Wow, I'm a bit faster than I thought. We can do a bit of the UI design. Okay. So to summarize, we have this concept of cohesion and coupling that help us when we do low-level design. Okay. In this class, I'm not teaching you how to do class diagram, but we can have cohesion and coupling as a way to measure the quality of your design. So cohesion is degree of relatedness. And the higher the better. While coupling is degree of interdependence, and the lower the better. You want things in the same module to be highly cohesive, which means they are related to each other, and you don't want them to have many connections with the other module. Okay, so that is the picture that we want to see. Okay, maybe I talk a bit about the last part. We have discussed the physical architecture design, the software architecture design, and the low-level coding level design. So the last part is about human-computer interaction design. This is one of the main things in software development, and it has its own field like human-computer interaction, HCI, or UI UX. Right? You can have one single course about UI and UX. So I'm not going to go into too much detail. But UI is one of the things in the software that are mostly apparent, or it's the first impression to the user. When you use the software, the first thing that you would see is their user interface. And the user interface can be problematic in two ways. So the first one is the flow of interaction is not good. This is called UX, or user experience. It's difficult to use. And the look and feel, which is UI, how beautiful it is, right? So when you design software applications, let's say mobile applications, and you upload it into the App Store, first thing that the user would see is your UI, how beautiful it is. And somebody might choose the one app over the other because one is more beautiful than the other. When you start downloading the app and then you start using the app, then the UX come into play. You might find that the beautiful app might not be very easy to use. And finally, you might even switch back to use the one that is not so beautiful, but is much easier to use. So UX and UI are two main components that the software must have a good balance and also provide benefits on both sides. Okay. So when talking about user interface, there are long time evolution. Okay. So the user interface can started from the very old command line interface that I just showed you before. So the command line interface are the interface that you have only the command prompt and you have only one single way of input, which is you provide the keyboard input. The only way that it shows the output is text, right? On the screen. So you cannot do much. You receive some characters from the keyboard, and then you get some text output showing on the screen. It is a very primitive user interface that we can have in all the computers right now. It can perform some of the basic operations, but it cannot do such fancy presentations like image or graphs. And then, like 20 years ago or so, we have this text menu user interface that the UI is created still based on the text, but you can see that they have more visual representation now. Okay, you can start using some mouse and keyboard to select things as an input, and then it can show some kind of minimum level of graphics. Now it can draw some simple pictures for you by combining the characters together. And then at the present, we would have these highly complicated UI that are created from many graphical interface. Now the computer get faster, the computation gets faster, you have more powerful graphic cards, and we have many technologies that can produce much better user interface. So the user interface nowadays, we would call them graphical user interface or GUI. Somebody called it GUI, right? So GUI is the main user interface that people are using nowadays. That you can have graphs, 3Ds, pictures, videos, so on and so on. Okay. The last thing is I want to show you that there are also other type of user interface that software can have. Okay, so let me show you this example of voice control interface. That gives you full control of your devices with just your voice, period. It's a whole new way to do everything you love, period. Like this. Correct love.
A list of numbered options.
16.
The word is replaced by a red heart.
Open photo.
Ian sits in a wheelchair in front of him.
Scroll up. Okay. Go down. 13.
A man with a bike.
Click share.
Share options.
3.
Messages.
7. Next field.
Ian composes a message.
Let's try this one today. That's that motion. Click send. Open map. Show grid. Long press and 20.
A marked location on the Pacific Coast scenic firewall.
Open app picture.
Ian's wheelchair mounted iPhone.
4. Tap here. Tap 10. Tap 10.
Now, Ian rides his motorized wheelchair across the pedestrian bridge over Blue River. Later, he was sipping puff controller to ride along the trail 2 by 7 2.
Hey, good here. Open music, turn up the volume.
Jimmy and the park from the Hosting Mountain Lake. And
You can see that this software is used purely using voice, right? So other types of user interface nowadays can be voice command or gesture-based commands. If you look at the new devices that coming out, like the Apple Vision Pro, the new one, Orion Glass, those things they based on your hands, right? So if you use your hands to grab something, that means some of the commands in the software. Okay. I think I would end my lecture today here, and we'll continue again next week to finish the user interface design and also starting the low code programming topic. Any questions? หิวแล้วหรือว่าแล้วปกติคุณทานเที่ยงครึ่งทุกวันเลยอ๋ออาจารย์เลิกเที่ยงทุกครั้งเลย Just kidding. Yeah, the teacher is hungry too. So that is all for today. Thanks for coming and see you again next week. Yeah.